Okay, so this question asks us to determine the angle of inclination correct to one decimal place of a straight line passing through the points uh, 2, x equals to 2 and y is equal to 1, -3 and -9. Okay, so let me just write that down, are the 2 points that we have. Um, so x2, y1, and our second point is -3 and -9. Okay, so if we draw that on a Cartesian plane, it looks something like this. We have our first point somewhere over here. That is 2 and 1. And then the next point is somewhere over here. Okay. And this point is -3 and -9. Okay, so first what we need to do is calculate our gradient, and m is equal to y2 minus y1 over x2 minus x1. So we can make this our x2, y2, x1, y1 values. And if we plug that in, so that is 1 minus -9, -9 over 2 minus -3. That gives us an answer of a gradient of 2. Okay, so m is equal to 2, right? So if we check, right, let me just draw this line over here and I'll show you what is actually going on, right? So we are looking for this angle, right? And if you check, this distance over here is going to be 9 plus 1. That gives us a distance of 10, eh? This distance over here, oh, let me just do it a bit lower. This distance from here to there is going to give us 2 plus 3, and that's a distance of 5, right? So we want to calculate this angle. So if we use trigonometry, right, we can use tan theta, which is opposite over adjacent, right? So we can, I'll just write that. Let me just move this to the side over here quickly. See if I can move this a bit lower. Okay, there we go. Move that to the side and move this to this side. Just draw a line over here. Okay, so tan theta, I said, is equal to opposite over adjacent, right? So meaning that tan theta is equal to, our opposite is 10 and our adjacent is 5. 10 over 5. So that means if we want to find out theta, we need to take the inverse tan, right? And you can see it's practically just the inverse tan. So theta is equal to that inverse tan, that the tan with that -1 at the top of 10 divided by 5, right? So practically, so this is going to give us an angle of, let me just check here quickly. So theta is equal to 63,4. So just to recap, to find the angle of inclination, what we practically have to do is, it's going to be theta is equal to the inverse tan, right, of the gradient, right? And you can see that 10 divided by 5 is equal to 2. So it's the inverse. So all you have to do is just find the gradient and then get the inverse tan of the gradient, right?